Okay, so yesterday we were discussing about networking concepts. Why we need to learn networking concepts in a cloud? Because every data center needs to be connected to the AWS at the end of the process. So that means, the entire infrastructure needs to be maintained through or communicated through network only. So that's the reason we need to learn networking concepts. Okay, as I told you, how many classes are there? There are 4 different IP classes are there. That is A, B class, C class, and D class. Okay, what are these classes? See, initially we don't have much requirement of networking the software or hardware components. Okay, but later on we have so many devices and so many components that needs to be communicated with each other. That is the reason they have simply enlarged the capacity of the IP addressing. That means they have gradually increased the number of IP addresses supports actually. So initially we have IP address classes A class, okay, and then B class, C class, and D class. What are those ranges? We have already seen class A basically have a range of IP addresses, something like you can say IP address range C1 to 127. Okay, 1 to 127. Is it clear? So what is the network mask value equivalent to 1 to 127? So it supports up to 255.2.0.0. Okay. So this is a network mask. And then coming to how many number of networks it supports. The number of networks it supports is 125 networks only it supports. Okay. So the number of hosts it can support, number of hosts. This class A supports are 16,000. Sorry. So this is an approximate figure. Okay. So this is the approximate figure supported by this class A. Then later on, as I said, this range is only the IP address range. This is IP address range. Okay. So IP address range. Okay. This is IP address range. This is network mask. This is network mask. Okay. This is network mask. Okay. Then class B, its IP range was started actually from 128 to 191. Okay. And then class B, its range is actually 192 because 191 ended with class B. So 192 to 223. Then finally class D. So currently this is the one which you are using. Okay. 224 to 239. Yes. Then finally IPv4 basically supports 142 to 254. Okay. So these are the various classes of IP addresses. Okay. IP address classes you can say. Okay. These are the various classes of IP addresses. Class A, Class B, Class C, and Class D. Class A range starts from 1000 to 126.255, and then Class B starts from 128 to 191.255. That means almost like 192. Then C class starts from 192. D class starts from 124. And E class starts from 240. Okay. Is it clear?
Yes, sir.
Okay. So these are the various IP classes that supported in modern days. Okay. Then what is IPv4 and what is IPv6?
IPv4, it is also networks.
Okay.
But
This is also network, okay?
IPv6 is somewhat advanced than IPv4.
Correct. IPv4 advanced than IPv6 is advanced than IPv4. Fine. So which one you are using? Which one comes under IPv4? 140 to 154. This is the range actually comes under a IPv4. Okay. So what are the public and private IP addresses? Public and private. What is the public and what is private IP addresses?
IPv4 is in a public.
Okay.
And IPv6 is in a private.
No, it's not like that actually. See, whatever, See, internet also has its own IP address. That means 0.0.0.0. This is actually internet. Internet, anybody can access, right? If they have internet connectivity. For example, you have a mobile. So you are going to some metro station. They have Wi-Fi. We are able to access that internet. How that is possible? That is actually public IP address. That is the reason we are able to. Public means anybody can access that IP address. Okay, then what is private? Private means we can't. These are categories. Okay, those are actually classes. These are actually categories. Categories of network. You can say public network and private network. What it is. Okay, see, let me tell you, under class A, there are again different IP address which supports private. Private means this is for home needs, home or individual, individual and the corporate level, corporate or companies uses a private network. Okay, see what are the private address ranges? Okay, for class A again, but the private address range is 10.0.0.0 to which range? 255.255.255. Sorry, 255. Oh yeah, 10 we missed actually, 10 dot. Okay. See, actually, what is the range it supports? The network it supports from 1 to 127. That means 000 to 127.125.125. Sorry, 255. Okay, but in this one there's a private address range. That means the private people are for home needs or individual needs or for company needs, or if anybody want to have their own network, they can use only these IP addresses 10.0.0.0 to 10.255.255.255. Okay, then class B, it also accommodates private IP range, private address ranges. This actually starts with 172.16.0.0 to 172.31.255.255. That's all. Okay. So that means in class B, it also supports private address ranges. What are the ranges it supports actually? It supports what's 172.16.0.0 to 172.31. To see, if you open any laptop or desktop, just search with IP address, IP config. This is actually a private IP address. What it is actually 192. If you look at here, so that means it supports in class C. Okay, I'm supposed to going to explain actually. In class C also, there's a private address range that starts with 192, 192.168.0.0 to 192.168.255.255. This is the range. That's the reason it's showing 162.168.29.112. Clear? Is it clear?
Yes, sir.
Yes or no? Yeah.
Yes,
So these are the private address ranges supported by various classes. Class A supports 10.0 to 10.255. Same time, Class B supports 172.172.172.60 to 31, and Class C supports 192.168 to 192.168.255. These are the private IP addresses it supports. Okay, is it clear?
Yes, sir.
Okay, now yesterday we are discussing about okay, what we are discussing?
IP addresses.
No, we are discussing about classless inter-domain routing, right? This is the one we are discussing about, right? So we'll see now what is classless inter-domain network. Class CIDR. What is the importance of CIDR? Basically, you are working some XYZ company. Okay, just assume you are working some XYZ company. How this company manages its network? How it is going to manage its network? Yeah, so it basically divides the entire network into subnetworks, right? So these subnetworks need a separate IP address. Similarly, in Amazon also need to maintain its subnets. Okay, just a second, I have to connect to the charger. Okay. So as we discussed last time, okay, so each Amazon entire network is divided into regions. Under each region, we have so many availability zones. Okay. So for suppose you are in US, okay. US has 4 available zones. As we know, 4 available zones are there. Okay, under US region. What is actually? So there is a okay. So notepad. Sorry. Yeah. Okay. Okay. Now here I'm going to draw. Okay. This is availability zone 1. Okay. Control C, Control V. No. Okay. This is another availability zone. Okay. This is another availability zone. This is actually, you can say, availability zone USA. Okay. So where is this? Okay. I'm going to draw one more thing. I will explain what is this later. Okay. Yeah. Okay. So this is availability zone 1. AB, AZ. Okay. AZ1. AZ1. This you can say US East 1A. Okay. This is also, you can say, this is also another availability zone, AZ2. This is actually US, okay, 1B. Just assume in East, US 1B. Okay. There are 2 availability zones. In this, actually, what we are going to do, we are going to create one private cloud, VPC. We call actually VPC, Virtual Private Cloud. We are going to create it. This, you can say, VPC. This VPC spread across 2 multiple zones. Please look at here. The VPC can be created in a different zones, availability zones. Under each availability zone, we can create our own subnets. We can create our own subnet. Just assume there's a subnet. Okay, there's a subnet. Okay, I'm going to create a subnet over here. This is one subnet. This is another subnet. Okay, this is one subnet, and this is another subnet. One subnet, this is another subnet. Okay. So what is the subnet? This we can say, I can make it actually private subnet. Okay, private subnet. Otherwise public subnet. Okay. This actually, you can say private subnet. Okay. So here also I'm going to create another public subnet. Okay. Here I'm going to create another private subnet. Okay. Private subnet. Inside the subnets, what I'm going to do, I'm going to add a okay, instances basically. Okay, I'm going to add an instance 1. This is instance 1, and I'm going to create another instance over here. Okay, so there's another instance. This is another instance. Hope you are clear. Yeah, this is
Yes, sir.
instance 1, this is instance 2, this is instance 3, this is instance 4. That means there are 2 availability zones. The VPC spread across multiple zones. So inside this VPC, what we are going to do, inside this VPC, we are going to create a subnets basically. One is a private subnet and the one is a public subnet. I will explain what is private and public later. So these are instances. So this is what we are going to set up entire network. Okay, initially, this is the initial part of AWS. So first instance 1. Okay, this is instance 2. Okay, this is instance 2. Okay, this is instance 3. Instance 3. Okay, this is instance 4, and so on. Okay. Now the question is how we are going to first of all create a network. As I told you, this is a virtual private cloud. Okay, this is also network. AZ1 is a very big cloud. It's actually AZ1 has its own network. AZ2 has its own network. These are interconnected again. As we know, these are interconnected. Why we have multiple zones? If there is any issue in AZ1, automatically AZ2 can act as a backup. Similarly, AZ2, if it is down, AZ1 acts as a backup. That's the reason. We always prefer to have our instances running on a multiple zones to avoid any kind of unforeseen risks. Okay. So now coming to our the current topic, networking. Okay. So what is networking? What is networking? So as I said, we are going to discuss about classless inter-domain routing. Okay, classless inter-domain routing. It basically helps us to allocate and calculate number of IP addresses we are going to allocate for each IP address. For example, okay, if you give an IP address something like 000, okay, something like 000 I want to give. Okay, so from this actually I can simply say 000 0.0.0.0 to okay, just assume 0.0.0.7. Now tell me how many IP addresses are there in this range? How many IP addresses are there?
7. 0 to 7.
No, 0 to 7. Count properly. How many IP addresses are there?
8, sir.
8. Correct. 8. Okay. So there's a small formula to calculate this actually. So if you give any classless interdomain network, it always follows a format saying that first IP address. Okay, with X value. Okay, what is this X value? X is nothing but a subnet mask value. Subnet mask value. That means if you are going to create any subnet inside from this IP address, we can use and we can specify the range of IP addresses we can allocate to those subnets. Okay. So for suppose they are given a very simple saying that 12.0.0.0 of okay, just assume 29. Now tell me how many IP addresses are there? How many IP addresses are there? I just gave an equation 12.0.0.0. This is the first IP address in the network. That means our IP address takes this is as the first IP address, and the subnet mask value is 29 over here. Then how many IP addresses this network can accommodate? For this, we have a simple formula called x equal to 32 minus, okay, please remember this formula, log 2 of size. Okay, log 2 of size. This is a formula we have to apply to find the subnet mask value. Okay, but here I don't want x, right? X a value I know already, 29. I want to know size. How do you know size? Now tell me. How do you know size? Just bring this log 2 of size onto left side, then automatically this equation will become okay, log 2 of size equals to 32 minus x. Okay, now just apply log 2 on both sides, then automatically log 2 base 2 will become 1, right? Size equals to 2 to the power of okay, that is just 2 to the power where yeah, 2 to the power of, okay, to the power of, what is this, 32 minus x. This is a formula to find the size of the size. Okay, to find the size, this is the formula you have to apply. 2 to the power of 32 minus x. Now calculate what is the size. Tell me. How many IP addresses you can allocate from this point? So this is nothing but a classless interdomain routing. This is a format actually. So it follows always okay, first IP address /x. X is nothing but a subnet mask value. By using this, we can find how many IP addresses this network can accommodate. For this, we have simple formula called x equal to 32 minus log 2 of size. Log 2 of size equal to 32 minus x, right? This is a very simple formula. And size equal to 2 to the power of 32 minus x. Now size we know already. What is the size? Size we can simply say x. Okay. Size you want to calculate. 2 to the power of 32 minus, okay, 32 minus 29. That's all. What's the value? Tell me. What's the value? 32 minus 29. 2 to the power of
2 to the power of
3, right? So how many IP addresses it can allocate? 8. Okay, is it clear?
Okay, sir. Okay.
If you are learning network, first and foremost concept, okay, it always 2 to the power of 2, power of 2, 1 thing. Second thing is actually network itself will consume 2 IP addresses. Okay, if you are going to apply subnets, each subnet occupies 5 IP addresses. Okay, so each system or a network or each hardware component in your network occupies another IP address. That means total, for example, if you are going to create a subnet, automatically it requires 5 IP address. On top of it only you have to, okay, allocate. You can't give simply 4 IP address since it is 2 to the power, because subnet, if you are going to create, the subnet itself occupies 5 IP addresses. So there is no use. Okay, so we should always give the subnet mask value always supports more than 25 when you are going to create a subnet. For example, I'm going to give here another example. Okay, I'm going to give another example over here. Okay, 170 or 150.0.0.0 of 60. Now tell me how many IP addresses it can give quickly. How many IP addresses supports? Yeah.
150 minus 16.
Right. 2 to the power of 32 minus 16. Okay, 16. See, whenever the subnet mask value is less, automatically it accommodates more number of IP addresses. Whenever the subnet mask value is very high, automatically it okay, accommodate less IP addresses. Otherwise, it will have a very few IP addresses. Now tell me, 2 to the power of 32 minus 16 means 2 to the power of
16.
2 to the power of 16. Then how many IP addresses it's accommodate? 2 to the power of 16 means how much? It's almost like 60,000. Okay, 60,000 IP addresses to accommodate. Okay, so and Okay, calculator, then 2 into 2, okay, into 2, okay. Otherwise, you can say we know already 2 to the power of 5 means how much? 32, right? 5, 64, 64, okay. 2 to the power of 8 is 256, okay. 256, sorry. So 256 into 2 into 2 into 2 into 2, okay, into 2 into 2, okay, into 2. Now how many times? Where is this? What? Oh, miscalculation basically. Okay. 256. It will become 2 to the power 8. That we know. Okay. 2 to the power of 8 equal to 256. Now we have to add one more 8 times. Okay. We have to multiply 8 times. Okay. 2, 2, 2, 2, 2, 2, 2. Okay. Now tell me how many times we have added. 250. Yeah. 1, 2, 3, 4, 5, 6, 7. One more time we have to add. Okay. Yeah. Then it will become 65,536. This is the approximate value, not approximately exact value. Okay. So if we give 2 to the, subnet mask value of 16, it can accommodate 65,536 IP addresses. Okay. Is it clear?
Yes, sir.
Let me know if you have any questions.
No, sir. Just only formula once again.
Okay. So classless interdomain routing. This is helpful to create a subnets with different IP addresses. So the formula is very simple. X equal to 32 minus log 2. Base value is 2 of size. Okay. So if you bring log 2 of size on the left side, it will become 32 minus x. So automatically you can calculate how many IP addresses it supports. Okay. For example, I'm giving one more example. 150.0.0.0 to 150, okay, .0.3. Okay, 255. Now tell me how many IP addresses it supports. Yeah, tell me quickly.
2 to the power of 32 minus 150. I think.
No. Why we are applying a formula here? I'm asking manually calculate how many IP addresses should be there. So how many IP addresses would be there?
Not getting it, sir.
Okay. See here we have around 256. Okay, plus. So after it is releasing to 150.0.1.0, okay, to 255. Here again you will get another 256. Okay, then one more 150.0.2.0. Okay, you will get another 256. Okay, then again another 256. Okay, so 120. So from here to 0 to 1 you will get 155. From here to here we will get a 156. From here to here another 156. Again we will get here another 256. Then how many IP addresses it supports?
1.
No, yeah, 6 4s are 24. Okay, and then 5 4s are 20, 24. Again another 4 and 28, 9, 10. 1044 IP addresses supports. Okay. Now tell me, I will give one more example. Okay. 14.95. Okay. 526.23 of 26. Now tell me how many IP addresses it can accommodate. What is the size of the CIDR?
2 to the power of 32 minus 26.
Are you sure?
Yes, sir.
First, look at the IP address.
14.95.23/26. 526.
So the question is wrong actually. So does it accommodate more than 255 in IP addressing?
No, sir, but it is on 526.
Yes. So that's why you can't give actually. So 26 of 26. Now we can calculate. Okay. Now we can calculate how many submask values you can. I mean, total IP address this CIDR supports. Now tell me.
Two to the power of 32 minus 26, sir.
How many IP addresses it supports?
2 to the power of.
If we give 16, okay, if we give 16, where is 16? Yeah, if we give 16, we know 16 means it supports almost 65,000.
65,500.
65,000 something. Okay, IP address supports. Okay, what about if you give 26? How many
2 to
IP
the power
addresses
of
it
6.
supports?
It is equal to 2 to the power of 6.
2 to the power of 6. Okay, how many IP addresses then?
2 to the power of 4 to the right.
So it supports a 64. Okay, yeah. If you give 29,
29 means one more IP address.
correct. If you give 30 we never give, which supports only 4, right? So for IP address, we cannot create any subnets. Okay, we cannot create any subnets because under subnets again we'll create so many other components like instances, routers, and so on. Hence, we can't create any. Okay, we cannot use 30. 31 also you can't use. 29 also very difficult to use. What about 28? 28. Yeah, how many IP address it generates? We give 28. 16.
16.
Okay, and coming to 24, shall I give for otherwise 27? 32. Right? 27 minus 32, 5, 2 to the power 5 equal to 32. Okay. What about 26? 64. Okay. 64. What about 25? What about 25?
120.
What about 25?
2 to the power of 32 minus 7. 2 to the power of 7.
2 to the power of 7. 7 means?
2 to the 4 to the 32. 64. 128.
Okay. If you give 25, it automatically give total IP address size of 128. Okay. So why we are learning all these formulas? And see, you should know, okay, subnetworking. When we are going to create a subnet, we should know does a subnet has a ample amount of IP addresses to create. If we don't have sufficient IP addresses, we cannot create basically. Okay, clear?
Yes, sir.
So that's the one thing. Next, we'll discuss about VPC. What is VPC and all? So what is VPC?
No ideas.
Okay. So we use IP addressing in various formats. As I told you, IPv4 addresses we use actually in especially in AWS cloud computing. Okay. First we'll create VPC like in our diagram. This is VPC. VPC is basically a private cloud. You can say this is a public cloud. Anybody can access, right? If you have a free tier, can you access the cloud or not?
Yes, sir.
Yeah, but if you create a VPC, others can't access your cloud. Okay, virtual private cloud means you are going to create your own cloud inside the public cloud.
Okay.
Correct? For example, you are working in some construction company where HR department is there, finance department is there. So finance department people cannot have an access to the material management. Material management people does not have ideally have any access to the some HR department. So what you are going to do? First, you will create a virtual private cloud because other than your company employee should not access your details, right? You are working next to your company.
Yes, yes.
So some others should not access it actually. Okay.
Yeah.
Others should not access. Hence, what you have to do first, we will create a private cloud. Inside private cloud, we keep on creating a subnets. See, whatever you are in, actually, that is a public cloud, public IP address. Okay, public IP address. Anybody can access the IP address. But inside that, what you are going to do, we are going to create our own private cloud. After creating a private cloud, we are simply connecting to the various subnet. Inside subnets, we are going to create instances. Okay. See, I'm going to create a one more table. I will save it better. Save as VPC. Okay. Control-N. Now I'm going to create a very simple VPC. This is a VPC. Inside VPC, I am going to create two subnets. Okay, I'm going to create two subnets. This is subnet 1, and this is subnet 2. Okay, this is subnet 2. Okay, so this is subnet 1. Just subnet 1 has a router. And the subnet, this also has a router. Okay, so here we have two systems, or we can say instances. Instance 1, instance 2. Okay, instance 1 and instance 2. This is another instance. This is another instance. Okay. Yeah. Now, this is actually can simply say, just remember this is a subnet. Okay, otherwise I'll write it here. This is subnet. Okay. Subnet 1. Okay, subnet 1, and this is subnet 2. Subnet 2. Okay, this is VPC. Okay, VPC, virtual private cloud, is a big under availability zones. We have created a VPC. This is our own purpose. Inside a virtual private cloud, we are going to create a subnets. Okay, inside subnets, we have a router. Whenever you create a subnet, automatically a router gets created. What's the router job? It basically controls the traffic and it provides an access to the various components of the subnet. That means if system A, this is system A. Okay, this is system B. Okay, this is system B. Okay, this is system C. Okay, system C. What about this? This is system D. Okay, so if A want to communicate with B, it cannot directly communicate. Hope you are clear, right? So it should come to router. From router, only it can communicate B. Okay, clear?
Yes,
Hope you are clear. Similarly, if A want to communicate with C, it cannot directly communicate with C. It first should come to A with A. Sorry, this router 1. Just assume this is a router 1. Okay, this is router 1. R1. Okay, this is R2. R2. Okay. So routers only basically decides the channel of communication. If A want to communicate with C, it cannot directly communicate with R2 because in subnet. So access restrictions will be there. So it cannot directly communicate with R2. but it can communicate with the R1 from R1. So it can communicate from a R1 to C. This is how actually you can communicate. Okay. Similarly, if A want to communicate with C, definitely you can do that through like this C. Okay. But suppose C want to communicate with A, how to do that? First, it will communicate with the R2. From R2, it will communicate with the S. Similarly, D also, if it want to communicate with the B or C, first it will communicate with R2. From here onwards, it will go and communicate with the A and
B.
You can say A, R1, R2 have ego problem. They cannot communicate with each other. Okay. So R1 communicate with C. Sorry, A can communicate with C through R1. A can communicate with D with R1. So R1 directly communicate with R2. R2 cannot directly communicate with the R1. A, B are in subnet 1. C, D are in a subnet 2. When they communicate, routers are the main communication channels where we are going to communicate or talk with each other. Basically, what is a route table? Route table contains source and destination tables. Okay. Oh, sorry. Okay. I need a table. Okay, basically a router contains source and destination. That means it simply defines the IP address and which one you want to communicate. Okay. For example, R1 want to communicate with R2. R1 contains the entry of the IP address of the subnet. Similarly, if R2 want to communicate with the subnet 1, R2 router contains the IP address of the subnet 1. Is it clear?
Yes, sir.
Okay, then only it will communicate. Otherwise, it can't communicate. Okay. Okay, we stop here for today. We'll catch up tomorrow. Okay. Yeah.
Sir, how can I practice this one?
No, first you need to understand theoretically, then I will show practice. Yeah.
Okay, practical level.